Good morning, ma'am. I can't hear you, ma'am. Just give me a
Yeah,
second.
good morning. Good morning, Vikrant.
Yeah,
How
yeah,
are you?
I can hear you now. Great. I'm fine, doing fine, ma'am. How about you?
Yeah, I'm fine. Thank you. And is your mentor is joining?
No, ma'am, they won't be able to join. It's a work day and they have meetings.
Okay. Okay, fine. So you can start your presentation.
Sure. Sharing my screen. Uh, so welcome to the dissertation Viva for my topic, which is graph-based semantic debugging in enterprise software systems using knowledge graphs. uh, Vikram Sewaj, and under the supervision of our cloud security architect, Mr. Somen Mukherjee. This is for the dissertation in the final semester of MTech in Artificial Intelligence and Machine Learning with NLP specialization at BITS Pilani.
Yeah.
All right. So the agenda would be I will be going over the motivation and the problem statement that we actually refined into this current state that we have. As we already remember from the abstract state, this was a very vague and a generalized topic. And through the process of this course, we've been able to narrow it down to bring a specific focus into it based on the gaps that we found in the literature review. So we'll be going over those and the proposed methodology, the implementation and the data sources used. And we'll also be doing a demo implementation where we'll be actually be able to see the current snapshot of the code being converted into TTL, into JSON, and then finally into the knowledge graph, which will be represented visually for the end user, which would be the developer or other stakeholders in the product development team, and how they will be able to interact with it and gain some benefits as opposed to your normal debugging techniques. So we'll be going through these. So what was the challenge that actually drove this? This was a personal challenge for me. I've been working in the industry for over 12 years now. And the most mind-boggling situation that you could ever run into are these intermittent and untraceable issues, which actually span across multiple layers and have so many intricacies, so many finer points, finer detailing that we need to look at before we even get closer to the root cause. So finding such issues is a big challenge because each of these repositories work in a silo.
Yeah, yeah, yeah. No. It's okay. Fine.
Got it, got it, got it. So all of these informations are contained in silos within the logs for each of these components. And today's modern day enterprise applications comprise of more than 20, 30 components easily because all of them will be responsible for following the single responsibility principle. We try to decouple the application into finer microservices and micro front ends so that's easier to maintain and manage. But though it is easier to maintain and manage and for production wise, but for maintainability, that becomes a huge challenge because we are isolating and we are scoping them out from each other's contextual view. So the semantic knowledge that would be needed and helpful had they been together in a monolithic repo, that goes away. So to solve actually these issues, what we decided to try out was that we'll try to create a knowledge graph out of three key inputs that we targeted. And this is what I'm discussing for what we have already implemented in my company. That was the source code. That was the customer facing documentation. And third, the most important thing, which has been really valuable to us, are actually the logs. So the logs to source code mapping, that really helps us to, pinpoint when a particular scenario occurs. This is what developers usually do when they are debugging such issues. They find timestamps where this log happened, and then they try to trace back the flows. Okay, this is because once that log statement appears, that is our certainty that, the code has reached to a certain point, and now it's going to carry the flow forward from there. So those points are really critical for us to be able to identify which flows are being triggered. So we'll be doing the fault visualization as well. We'll be showing you that in the demo. And since this is the current product that we are working on is an actually not a purely software product, it's a hardware and a software product. Software is complementary to the hardware. It's primarily a hardware product wherein we are creating large video walls and desk operations for control room centers. So this is a very heavily dependent on infrastructure, network, hardware, and then the software part comes into the play. But software being software is where actually all of the things need to come together, get aligned, and every error that comes will have the only possibility for us to track it is using the software and the capabilities that it provides. So as I mentioned, we have covered the source code, runtime logs, and the configurations. Exclusions, as originally discussed in the mid-term report as well, ma'am, I won't be able to share any of the ontologies or the snapshots of the actual
You
graphs that.
can always show the
Correct.
sample, right?
Correct, correct. So for that, ma'am, I have a sample repository that I took from GitHub. It's a simple mean application with a front end, back end, simple CRUD operations, and we'll be using that as a sample for the demo implementation. So we'll be doing that.
Okay.
For the literature review snapshot, based on your inputs, I jotted them along the different timelines and to figure out, which things helped us where. So this is the current snapshot where the code to graph formed us. Will be able to how to parse the code into AST. This was something that we did not really learn in our lectures, but definitely it was touched upon in the NLP classes where we talked about NER and the recommendation and classification algos. So using those, combining those entities, even though I did not have to do this myself, there were existing libraries that did that. So I have used those libraries to create those RDF triplets, but of course the ontologies and how we are going to transform the different methods, service methods will go through all those tracking and extracting we have done as part of our implementation for this demo. So this is somewhat of a repeat effort that I had to do. This was done for our original code base, which was in TypeScript and Python. And the TypeScript part I had to modify a bit to be able to work with this demo repository that we have. So the whole process will be is designed in a way that it need not be a historical data that we are looking at. So we don't want to look at a knowledge base snapshot of the code 1 month back or 2 months back. We want to see what is there now because that is what is relevant. That is where the issues are occurring. So the pipeline is structured in a way that will be in the data integration part will be taking the current source code that is there from the latest branch. We'll be doing the parsing and extracting the triplets, and based on the ontology design, we'll be converting those triplets into JSON so that it is easier for to be consumed by a TypeScript repo, which is our sample repo. And we'll be doing the construction of the knowledge graph, and we'll be able to filter based on the RDF types and the SPARQL queries. So this whole process is designed so that with every release build, or we can do it on an ad hoc basis as well, we should be able to create a knowledge graph of a given branch. So that really helps the developers to even compare. Like what was the state of the application before I made the changes? What were the flows like? And now that after I have made the changes, what flows have changed? So that visual confirmation for the user, it helps them for the developer, it helps them gain confidence and certainty that indeed these changes that we see in the knowledge graph visually are what we had designed in in our original approaches. So the granularity we have kept to up to the function calls. We are not current. So the granularity would be we are talking about components, and then the function calls the function methods of those components, services, their function methods, and the functions that these services or methods call themselves. One deeper down level would have been more beneficial, but for the sake of time, we have not gone into that depth. So currently, this will be based on the function calls and the respective calls that go into those functions. So implementation details, this is what we have used for our this entire set that we see currently is for, sorry, I have gone up. This entire set is for what we have used in our enterprise application, and a subset of this with the few differences like for seeing the KG library in the graph database, we have not used these heavy libraries. We have used a lightweight JavaScript only Communica library to actually construct the knowledge graph. And we are running the Sparkle queries locally from the Node.js, from the browser itself. And instead of running an entire different server, because I wanted to keep it lightweight and simple. So based on the original code source repository from Barco, that is the organization that I'm working with, we were able to extract. Now this is in mind. This is we have done this for two components in terms of functional architecture level components. One is the front end and one is the back end. Our entire product consists of much more components. And even with these two components, the graph was becoming a lot messy because, as you can imagine, 12,000 triplets being trying to map on the screen, it already becomes a huge fuss. So those filters and those SparkQL queries really help to actually clear out the mess. So we can now go for the demonstration where we'll be doing these four steps. First, we'll be taking the latest code, we'll be seeing the code, and we'll be converting into RDF triplets. We'll go ahead then and then visualize the knowledge graph based on those triplets and JSON data that we convert into a demo UI that we have created specific for this presentation. Then we'll do the filtering of the knowledge graph based on the different RDF types that we have. And then finally, the most beneficial stage would be the SparkQL query execution, where we'll be able to execute SparkQL queries. That there will also be a logical next step to this, wherein we plug in an LLM and create these SparkQL queries based on the user's prompts. Because honestly, these were very difficult to create even for me. For this demo, I had to, I had to learn about SparkQL, and even though it's just basic, normal like SQL queries only, but not quite. We have to be very careful of the prefixes and the formats that we use in this query. The syntax alignment was a bit of a challenge, and so that is why the logical next step would be to plug in an LLM and get those SparkQL queries generated automatically based on the user's natural language prompt, which we have again not done in this demo because of licensing issues. All right. So first, I'll quickly show you a runtime of the application. So this is the demo repository that we have created, where it's a simple front end. We have an employee list, and we have the capability to add employees, and we can have positions, and there are validations that it must be 5 characters. So this is an existing repository that I have picked from GitHub. I will be sharing the link with you. I have not added in the presentation, but maybe I can add that in the presentation itself. Going into the source code of this, this is the repository where we can see that's packages and it's a Node application. This is what most of the modern enterprise applications are using. So this way it was a good fit for us. We have a front end in the client, which is an Angular front end, just like we have in our product. And then for the server, we have a Node module. So we have a mixture of Node and Python backends. But for this application, for this demo, this will suffice for us to have us a Node backend and an Angular front end. So if we go into the front end a bit, I just wanted to show you the different components that we see here. We see add employee, edit employee, employee form, employee list, app components, and each of these components are internally using services. And all of this information, which is contained in the source code as a proper Angular fully decorated file, will be now converting it into the abstract syntax tree and getting the triplets out of them based on the ontology that we have designed. So for this, the entire logic that is used for extracting and creating those ontologies is within this ASP folder, wherein we have these component parsers, method parsers, service parsers, template parsers, and then finally a triple writer that will be used to actually keep appending the list with the triples that we are able to extract from this. So this is the core heart of the extraction process, where we actually go for the different decorators that are there, different attributes of the decorators, and based on the decorators, we are adding the name nodes to our triples file. And similarly, this will parse the component decorator. This will parse the actual method, and the method which call is being made, which different functions or different service calls are being made from that particular method will be extracted in this parse method. Then there's similarly, just like we had a component parser, we have a service parser where we'll be able to parse the different methods and the different metadata of that service. Similarly, for the template, because we also want to, it's very important for us to know the basic, very different input or trigger points of most of our flows. Because being a full stack application, all the actual flows of the application will be triggered by the front end, by the user. So this becomes a very important, crucial information for us to know that which operation actually led to these flow of events. So tracking this information is responsibility of the template parser. And then, as I mentioned, this triple writer will be able to actually just create that entire chunk and write it as an RTTL file. We have all of these are independent modular functions that can be copy pasted and taken up in any repository. And this parse angular method is where we actually bring all of them together. We let the project know that currently we are looking at the front end code and give me the triples created from the front end code. It will go for all the service metadata, component metadata, template bindings. And on running this, let me quickly run this for you as well. So this file that we just show, parse angular, this will actually create the TTL file wherein it will contain all the triples that we have extracted from the source code. I have executed it, takes some time, and this is the output of this file. As we can see, it has all those app components, add employee components, services. We have the type as Angular service. We have the relationships where it relationships like has methods, calls, type, has method is bound to all this bound to is a template event. All these relationships from the source code we've been able to extract in a TTL file. Now, this TTL file can be easily consumed in a Python backend, but since we are using a TypeScript front end as the sole orchestrator of our demo, so we had to also plug in a TTL to JSON converter where we do the conversion and the sanitization so that these triples are will be able to easily read within the JavaScript object notation. So the output, now that I have created the TTL file, let me quickly create the JSON file as well. This happens quickly. And this is the graph data JSON that finally gets created. And as you can see, the difference between the graph.ttl, that was a simple TTL file containing triples, comma separated values. But this is a complete JSON object that can be directly consumed by my front end. So this was an additional step. This was just done so that this logic of converting, I don't have to do it on the front end. And this data should be now readily be able to be consumed within my demo application. So now that we have, this will be the final data that gets consumed. All the rest of the stuff is only needed to actually get to this point where we have this JSON. Now this JSON can be used to create this knowledge graph. This is the demo application that we have created. It takes a minute to settle down based on the number of components that we see. And this is just the graph that we see for the front end module. And as you can already see, it is very difficult to make any sense out of it. And this is the feeling that every developer has when he goes into the code base and, tries to make some sense out of it. This is what happens. So where this now
Did you
knowledge
explore,
graph is
like, did you explore here, like, where you said every developer has a difficulty here, right? To have
being.
this kind of, like, did you explore, is there any other methods available to
No,
have?
this is about the the developer's experience whenever we enter into a new repository, whenever we enter into a new project, and that is where we have when we have the least context and least knowledge of the product altogether. So once a developer spends a couple of sprints or maybe a couple of months in that product, then he's very comfortable. He knows most of the stuff because he has started working on it. But when he's new, for the new people joining the project, that is where it's actually a challenge. And I there are only things that can help really is at that point are the readmes and the documentation files. And as you might be aware, developers try to skimp on that. It has to be a very hardly chased item for the project management for us to add, extensive documentation, because based on the delivery timelines and the pressures that we have to meet release dates, the documentation always takes a back step, and that is the last thing that we do for each release. So that documentation is the only thing that can help that developer at that point. But now that we have this the information available visually, let me show you how this helps. So I have these. So these is essentially the two kinds of ways that you can interact with the graph. Either you do it by filtering based on the different RDF types that we have exposed here, or you can use the SparkQuell query. Right now, though, both of these don't work in conjunction. These are separated. In an ideal world, these would be working together, so that even if I run a SparkQuell query and I try to filter the components, that should work. Right now, it doesn't. So let me take you how, and actually I will be able to see this helps. So I go ahead and deselect all, and now the graph is empty. And now I will start to build up on my knowledge of the application. I will first go and I'll see what are the different components. Okay, I see that there are these 5 different components, and we also see the hierarchy. This information itself, if I try to find through the code base, I will need to do at least 4 to 5 different searches, and then I'll try to make a mental mapping of what goes where. With a single click, this information is now available to the user. Okay, these are the different components. Along with components, I also want to see services. Okay, there's just one service, employee service. I want to see what all functionalities is contained within these components. So I open the component method, and now I'm able to see the different components that these different functions that these components have, and this starts to give me an idea of what these components will be responsible for. I also go and check which all components are actually handling errors, because the error management is where the critical operations happen. It's where mostly the backend calls will be made. And as you can see, edit employee and add employee are indeed the node that will actually be going to call the HTTP services towards the backend. And we can see that the important error blocks are already there. The error handling is done here. To increase on this, now we can go to the function calls to see this function, what exactly does it does. Now, this is the layer that I told you that the last granularity that we have is what functions are being called from a components function. Ideally, we can do it in a recursive manner as well, wherein we can now go into that component and see what it traces, and then go into that component and see what it traces. But that will, I tried that. It also pollutes the graph a lot. We will run into so many cyclic dependencies, so many cyclic graphs because if we go into the recursive mode, most everything is connected to everywhere. So those graphs don't really help. So this granularity level where I'm able to see the function and the calls that are made from that function, this is really helpful. Now, these are the RDF types that my parser that we have written is able to extract successfully. Now, there are other elements as well that it was able to extract, but it was not able to map them to anything. And that is why they are coming under the unknown category. So these are mostly your imports that we do of the radio module, mat card module, reactive forms module.
Do you come across, is there any node that has maximum number of the edges incoming or outgoing edges?
We
Is
will
it
be able to see
relevant
that,
for
yes.
your work also? Huh?
Yeah, that is very
Mhm.
relevant for our work.
Mm.
What I can do is I can open my function component methods, and I can do the function calls. So now in this view, you can see which are the most highly outgoing ones. Delete employee, add employee are the most outgoing edges. As you mentioned that we want to know the connected edges and all. So this way we are able to extract that information using the filters. So and you can also write a SparkQuell query for this, wherein you will be able to see directly the maximum one or the top three or anything like that. You will be able to query that information as well. And this information right now just we did with 2 clicks. If I had to find that out from the code base, it would take me at least, I would say, being optimistic, three to 4 minutes. And this is just for one thing that I wanted to see. Similarly, there can be so many questions that we have to deal on a minutely basis, not even on a daily basis, when we are dealing with bugs and new implementation approaches. So even though the intent for this was actually for critical bugs, but what I have come to see is even when new features are being designed and the approaches are being discussed, that is also where this graphs have a lot of value.
So did you evaluate this knowledge graph with your data set? Like, is it all the nodes, that triples, every object subset?
That I have not been able to do, whether the coverage is 100% or not. But what
Mm,
indeed I have done is the data that is being spit out and is visible on the knowledge on the visually the knowledge graph is indeed correct. I haven't seen
mm,
any false positives there. And this is just manual inspection only, ma'am. It's not that I have written a script or anything for that. This is manual inspection only. Like I haven't seen any node which should not belong there, any edge that should not belong there, because it
mm,
is actually extracting. And if it is able to extract the type of the element, type of the triple, then I have good level of certainty that it is going to match with the right places. For unknowns, that is always the case that there could be some false positives here, because my parsing algorithm itself has said that I don't know much about this triple, much about this node, but I'm still recording it for you to make sense of it what you can. But I won't be able to query against it because it doesn't have its own type.
mm, mm.
So let me just reset the view. This was about the filters. Now we go into the Sparkle queries. So the thing about Sparkle queries is they are complex, but they are useful. And that is why I have added this list of saved Sparkle queries that I have created, and I see that they are working and they are helpful. So if we go ahead and select the one query and we do a run, it gives us the components that are actually calling an alert method. It's actually alerting the user. So if we know where all are we using alerts to inform the user of, because there are multiple ways to inform the user. There could be a toaster notification, there could be alert notification, there could be information banner that is displayed on the user. But alerts actually are more crucial and important for us to identify, because they have the capability to actually block our end-to-end tests. Because once the alert is open, and if you don't close it or accept it, you are not able to operate on that application, or you are not able to proceed with the automation script that you have written in Selenium or anything. So we try to minimize the use of alerts. So this was one query that let me just mind you again that this is a very simple lean repository, so the examples are going to be simple as well. So
Mm.
like for this one, this was a good example that I could find from this, that find all the error handling pros that are there from the component, so that I know where is the crucial logic that I need to be aware of.
Mhm.
So this gives us the error handling clause. Let me just reset the view so that we are able to see it properly. Yeah. This UI is not that friendly right now, I understand, but I hope we are able to see the actual benefit of this. And I want to see all the event bindings that are there. So it shows me that add employee has a lot of event bindings to form submitted, which is expected because this is the form, and in the form a lot of validations are there. So we know this gives us a picture user validations, where front end validations, where are they being applied the most, which application has the most front end validations, because this is also an important check that whatever validations are being applied at the front end should also be available at the back end, so that our APIs are also protected against the bad requests. Otherwise, what a super user can do is they can even manipulate the payload of the API and send data that should have been rejected by the front end validations, But and hence this lets us know where all we need to check in our backend whether these validations are being applied or not. This gives
Mm.
us a good idea in a one single snapshot. Okay, this is the list of backend services that I need to check for these validations.
Okay. Okay, Vikrant, you have any other things to discuss?
No, ma'am. Mostly it was just about this end-to-end flow as well, because this is where we are actually crossing the boundaries. It's not a completely connected graph yet, because there are some gaps in the current implementations. But once we nail that down, this will be a completely connected graph. We'll be able to see the complete end-to-end flows from the front end happening to the back end, even to the database.
Yeah. So here, what I feel is like, the user experience, is very basic. I feel, and it does not actually explore the studies with the testers or
So
developers. Validate whether this
that's what, ma'am. You're
the
completely
creative
right, ma'am.
visualizations
Correct. So for
genuinely improve the debugging workflows.
within the
So,
organization, ma'am, we are using Neo4j for the graph
mm,
representation, and that has a lot of filters and everything on its own. This is just the demo UI for this presentation by Viva, ma'am. So this is very bare, very minimal. I just try to make it functional. I did not care about aesthetics at all for this one. And I understand that that has left a bad taste in your mouth, but please do understand that this is a rework that I had to do only for the purpose of this demo, because
and also the evaluation metrics also, like how you uh,
oh no,
the
ma'am. Those
quantitative, yes.
evaluation metrics were those were estimated values, and that I was not able to complete, ma'am. Sadly, in the last 15 days, I was under the weather. I had to be hospitalized as well, long
Okay,
running fever.
okay,
So
sorry.
because of that, I did not even I was not even able to go to office, and that was
Okay,
when I had actually planned all of those concrete values to be put in there. But sadly, that is not there, ma'am. That is why I've removed that from the presentation as well.
okay, okay, Vikrant, all the best.
Thank you so much.
Okay, for your degree. Okay, so yeah, fine, bye. Thank you.
Thank you, ma'am.